The velocity of an object is defined as being the change of that object's position with respect to time. So we have a simple equation here, just velocity, average velocity of an object is just going to be delta d, so change in distance, divided by delta t, the change in time. And so in the example that we have in front of us here, we have a pretty straightforward circumstance. We have a car that stopped at a red light, takes off, travels a distance of 425 meters in 30 seconds. And so we want to calculate that average velocity in meters per second, and then later in kilometers per hour, and then in miles per hour. And we're given a conversion factor there to jump from the SI to English units. So we'll start off using our equation, so delta d over delta t, and the change in distance is the distance that the car travels, that 425 meters. Our change in time, the delta t, is going to be that 30 seconds that the car travels. And so if we divide that and then round to 3 significant figures, since that's what each of our measures is rounded to initially, we're going to get an answer of 14.2 meters per second. To get our result in kilometers per hour, we're going to start off with that exact same calculation, 425 meters over 30 seconds, but now I'm going to need to use some conversion factors. So I need to get from meters to kilometers, so we've got 1,000 meters in 1 kilometer, and then we've got to convert our seconds into hours. So we could go from seconds to minutes and then minutes to hours, but hopefully at this point we know that we've got 3,600 seconds in 1 hour. And so again, if we just push buttons on our calculator and then round off to the same 3 sig figs, we're going to get an answer of 51.0 kilometers per hour. And then finally, to get an answer in miles per hour, we're going to take all of that same work that we have here, and we just have one more conversion factor that we have to multiply by, which is going to be 1.609 kilometers is the equivalent of 1 mile. And so then again, if we perform that calculation there and then round off to 3 significant figures, we'll get a result of 31.7 miles per hour. So really we just have a very simple calculation, change in distance divided by change in time, where we're just doing the calculation in a variety of different units, so we just have to use a variety of conversion factors to get through it. Acceleration is defined as being the rate of change of the velocity of an object with respect to time. So we take the delta v, change in velocity, divided by the delta t, the change in time, to obtain acceleration. And so we can find the average acceleration of an object if we know those two changes in velocity and time, as we see in the example here. So again, we have a car at a red light, it stopped. 40 seconds after the light has turned green, the car is now traveling 60 kilometers per hour. So we're asked to find the average acceleration during that 40 seconds in meters per second squared. So the units for acceleration are meters per second squared or feet per second squared if we're in English units. So I'm going to start off with our equation, delta v over delta t. So our change in velocity, we're ending up at this 60 kilometers per hour, and our change in time is 40 seconds. So we can clearly see that we've got some dimensional work that we're going to have to navigate our way through. So I'm going to rewrite this expression just a little bit to make it a little bit cleaner for us to see the cross-canceling and the conversion factors that we're going to need. So I'm going to start with the 60 kilometers per hour, and then I'm going to multiply that by 1 over 40 seconds. And so when I write it like this, I've got everything either in a numerator or a denominator and not in the form of a complex fraction like we see here. And then I can also see that my dimensions are on track for being where I need them to be. I've got distance in the numerator, And then I have 2 time units in the denominator, so I am going to end up eventually, after I'm done with my conversions, with length over time squared, meters over second squared. So my conversion factors, I've got to get that kilometers into meters. So we know that 1 kilometer is 1,000 meters. And then again, I've got seconds, but I need to convert the other hour into seconds as well. So I've got 1 hour is 3,600 seconds. And so now I'm at the button pushing point of my problem. And again, rounding to 3 significant figures like we see in our measurements, we get an acceleration of 0.417 meters per second squared.